Greetings students. Today we are going to see the project scheduling using the method of PERT. So how to find the critical path and mean project duration using the method of PERT. Okay. Let us see this method by taking one question. Consider this following project details. Activity is given along with 3 time estimates. If 3 time estimates are given, this can be done in the project. This can be solved only by the method of PERT. Instead, if you are given with single time estimate, then you can use CPM method to find the critical path. Okay, so here 3 time estimates, namely optimistic time, most likely, and pessimistic times are given. So this can be solved only by using method of PERT. Let us see how to do this. What are all the things you have been asked to find? Find the path, that is critical path, and standard deviation. Also find the probability of completing the project by 18 weeks. So this is second part of the question. For this will come later. First part is finding the critical path, mean project duration, as well as the standard deviation. How to find it, we'll see one by one. So first, from the given table, you have to first find the one more column called mean estimate. That is mean duration of each activity as well as variance of each activity. So in the given table itself, I'm going to frame 2 more columns. I'm going to frame 2 more columns, namely mean and variance. Okay. So if single time estimate is given, easily we can do it by CPM. The same CPM method we are going to adopt here also, but with simple change. What is that? The 3 time estimate, we are going to bring it to the single time estimate by taking average, that is mean. So we are going to find mean value as well as the variance value for each of the given activity. What is the formula to find mean? T naught. So T naught general notation is for T naught it is A, for TM it is B, for TP it is C. If I take, then the mean is calculated as A plus 4B plus C by 6. Okay, T naught plus 4 TM plus TP by 6 is the formula to calculate mean. Variance is calculated by using the formula C minus A by 6 the whole square. That is pessimistic time minus optimistic time divided by 6 the whole square. These are all the formula to calculate mean and variance of each of the activity. Let us find it one by one. So first, for the first activity A, 6 fours, a middle one, you have to multiply with 4, add with the first and last, divide by 6. That is mean. Okay. 6 fours are 24 plus 9 plus 3 by 6. Means 36 by 6, that is 6. 5 fours are 20, 28, 30 by 6, 5. 4 fours are 16, 24 by 6, 4. 4 threes are 12 plus 10 plus 2 by 6, that is 4. 4 threes are 12 plus 11 plus 1 by 6, that is again 4. 6 fours are 24 plus 8 plus 4, 36 by 6, that is 6. 5 fours are 20, 35, 36 by 6, that is 6. Variance is calculated by taking difference between pessimistic and optimistic and dividing it by 6 and then squaring. Will give you variance. So 9 minus 3 by 6 the whole square, that is 1. 8 minus 8 minus 2 by 6 the whole square, that is 1. 6 minus 2 by 6 the whole square, that is 0.44. 10 minus 2 by 6. 10 by 8 by 6 the whole square, that is 1.77. 11 minus 1 by 6 the whole square. 10 by 6 the whole square, that is 2.77. 8 minus 4 by 6 the whole square, that is 0.44. Again 15 minus 1 by 6 the whole square, that is 5.44. These are all the mean and variance. So hereafter for duration of activity, we'll take this mean duration. Okay, instead of simple duration, here in this we'll take mean duration. First, let us frame the network from the using the information given, activity and the predecessors. Okay, using these two columns, let us first frame the network. So here A has no predecessor, B has no predecessors. Means A and B are nothing but starting activities. A and B. Okay. And then C, the predecessor is A. So just C in the predecessor column, C is there. Yes, C, it is not alone, it is along with D. So C and D together. C after A, D after B, both combines. C after A, D after B, both combines. Later we'll see. E is after B. E is after B. E is there in the predecessor column, but it is alone. It is not combining with anything. So I can draw this. F is after CD. So I have combined CD in single node. From that node, F, the activity F starts. And G is after E. It is ending node. We cannot have more than one ending node. So I am going to merge it with this. G is after E. Okay. So let us name the nodes 1, 2, 3, 4, 5, and 6. What is duration? So duration of each activity is nothing but mean duration. So duration of A is 6. Duration of B is 5. We have calculated no mean duration. Duration of C is 4. Duration of D is also 4. Duration of E is 4. Duration of F is 6. Duration of G is 6. Next, we have to find earlier starting time and latest completion time for each of the nodes. Let us find earlier starting time and latest completion time by method of forward pass and backward pass. Okay. So how to find for each activity? Earlier starting time and latest completion time. So for activity A, that is from 1 to 2, activity B from 1 to 3, activity C from 2 to 4, activity D from 3 to 4, E from 3 to 5, F from 4 to 6, G from 5 to 6. Corresponding earlier starting time. First, we'll start with 0, 0 for initial node 1. For node 2, it is 0 plus duration 6. So it is 6. For node 3, only one activity is getting in. So it is 0 plus 5, that is 5. For node 4, there are 2 activities coming in. So we are going to calculate maximum of 6 plus 4, 5 plus 4. So which one is maximum? 10. Okay. For activity 5, only one activity is coming in. So it is 5 plus 4. That is 9. For activity 6, there are node 6, there are 2 activities coming in. So it is maximum of 10 plus 6, 9 plus 6. So we have to find the maximum. So earlier starting time and latest completion time we'll calculate for each nodes. Okay. So there are actually 6 nodes. So for each node, let us calculate the activity. 1, 2, 3, 4, 5, 6. Okay, 10 plus 6, 9 plus 6, maximum is 15, 16, so 16. Okay, 1, 2, 3, 4, 5, 6. So this is active. Actually, the initial node 1, the value will be 0, 0. So we'll start with 2, 2, 3, 4, 5, 6. This is what we have done. Latest completion time, it is backward pass. We'll start from the last one, which is same as the 16, the earliest starting time we have got. So start with the last node, 16. You have to go in the reverse way. For node number 5, only one activity is going out. So it is 16 minus 6, that is 10. For node 4, only one activity is going out. So 16 minus 6, that is 10. For node 3, there are 2 activities going out. So we have to go for minimum of those 2. Minimum of 10 minus 4, comma 10 minus 4. So 6. Both are 6. So it is 6. For node 2, only one activity is going out. So it is 10 minus 6. That is 4. Sorry, 10 minus duration is 4. No, 10 minus 4. That is 6. Next, for activity 1, it is there are 2 activities going out. So minimum of 6 minus 6, 6 minus 5. So minimum is 0. Yes, we have got it 0. Already we'll fix both. We need not find it actually. We'll cross verify whether you are getting 0 and latest completion time for the first node. Okay, this is how we should calculate ESI and LCJ by forward pass and backward pass. Then we have to find the critical path. So from 1, there are 2 paths going, namely 2 and 3. So check which one is equal, both the ESI and LCJ, both triangle value and square value, 6, 6, 6, 5. So only in this both are equal. So I'll just choose this path. From 2, you have only one path, namely 4, where both earliest starting and latest completion are equal. So from 2, I'll just go to 4. From 4, there is only one path that you have both earliest starting and latest completion equal, 16, 16. So from 4, I move to 6. So the critical path is 1 to 2, 2 to 4, 4 to 6. That is in terms of activity A to C to F. Okay. Mean duration, mean project duration. Mean project duration is nothing but the mean duration associated with each one. Okay. 1 to 2, 2 to 4, 4 to 6. That is corresponding to A, mean duration is 6. Corresponding to C, mean duration is 4. Corresponding to F, C, D, E, F. The mean duration is 6. So total is 16. Duration is given in terms of B. So it will take 16 weeks to complete the project. Okay, the first part of the question is over. What is the second part? You have been asked to find. The probability that the project will be completed in 18 weeks. So we have to find the probability that the project, let it be capital X, project will be completed in 18 weeks. That is within 18 or less than 18. So it should be completed in 18 weeks. So either 18 or less than that, not more than that. So this probability we need to find. For that, we are going to find it using normal distribution. What is normal distribution? Z is equal to x minus mu by sigma, where mu is mean and sigma is standard deviation. So to use this, you need to find what is mu and sigma, mean and standard deviation. Already mean and variance we have calculated for each activity. So I'm going to use that mean and variance value which we have calculated I'm going to take it for the critical paths alone. What is critical path here? A to C, C to F. So this is critical path. So only for this critical path, let us take the mean and variance value. So 6, 4, 6 and 1.44, 0.44. So let us take the critical path. For that critical path, let me find the mean and standard deviation. So what is the critical path? A to C to F. Mean at A it is 6, C it is 4, F it is 6. Variance at A it is 1, at C it is 0.44, at F it is 0.44. Find the total mean, 16. It is total duration. Generally, total mean of critical path is nothing but project total duration. And variance is 1.88. So let it be mu, mean of the project. And this is variance. What is the notation we use? Sigma square. Actually, to substitute a normal, we need sigma, standard deviation. So from sigma square, let us find sigma, which is square root of sigma square, that is 1.88, which we have calculated as 1.37. So finding probability of x less than or equal to 18 is same as subtract mu and divide by sigma on both sides. So x minus mu by sigma is nothing but z less than or equal to 18 minus, what is mu value? Project mean 16, sigma standard deviation 1.37. So probability of z less than or equal to 18 minus 16 by 1.37 is 1.459. Okay. The normal distribution table, we have to find what is probability of z less than or equal to 1.459. Okay, which can also be probability of z less than or equal to 1.459. Okay. So finding this value from the table, even you can find it using calculator. What is the method? First, fix the calculator in SD mode. Then press shift 3, which will on the display you will get P of, Q of, like that. Okay, so select P of, which is 1. So on the display you will have P of. So in that you type, what is the value? 1.459. Type 1.459 and close the bracket. Press equal to, you will get the value. The value is 0.9277. So this value, finding the value of P of Z less than or equal to 1.459 using calculator, the same as finding the value using normal distribution table. Okay. So the probability of completing the project by 18 weeks is equal to 0.9277. In percentage, 92.7% we will complete the project by 18 weeks. Clear? Thank you.